So we are going to solve a numerical which is based on the track error and the closing angle. The problem is that the aircraft travels from point A to B. Actual time of departure is 1000 hours, and at 1024 hours the aircraft is found at position X X-ray, which is 80 nautical miles from point alpha, that is the starting point, and 6 nautical miles to the starboard of track. The pilot gives a correction at this point X-ray and maintain a heading of 082. And at 1048 he again find out his position, and the position is at Yankee, which is 100 nautical miles from X-ray and 2 nautical miles to the port of the track. Now the distance to Bravo is 120 nautical miles. Find the heading to turn to his destination Bravo and the time of arrival at point Bravo. Right? So we will solve this. In order to solve this kind of a problem, I need to draw the line. So let me pull this up. Okay, here is the question. Now, in order to solve this kind of a problem, you need to draw the track line. Okay. This is, let's assume that this is point alpha and this is point Bravo. I need to draw a line joining point alpha to point Bravo. Now the time of departure is 1000 at point alpha, and at 1024 when he fixes the position, he found himself at position X-ray, which is 6 nautical mile starboard of the track. Okay, 6 nautical miles. This is 6 nautical miles starboard of the track. At 1048 the pilot again fixed the position, okay, and found himself 100 nautical miles from point X-ray, and this is Yankee. The distance between them is 100 nautical miles, and he found himself to be at the port of track by 2 nautical miles. This is at time 1048. Now this is 80 nautical miles and this is 100 nautical miles. At point Yankee, the distance to point Bravo, that is his destination, is 120 nautical miles. 120 nautical miles. Find out the heading to turn and the time of arrival. Now I will solve this for each and every leg. The first leg you may not require to solve it, but I will solve it for the practice. On the first leg, I need to find out this angle. This angle is nothing but the angular difference between the track required and the track made good. The angular difference between the track required and the track made good is known as the track error, okay, which will be annotated port or starboard depending upon the track made good lies port or starboard of the track. Here in this example, the track made good is onto the starboard of the track, so therefore the track error is gonna be starboard. Once we find out, we will annotate or assign them as starboard. Now we need to find out the track error, that is this angle. We will find out the track error by using the 1 in 60 rule. So therefore the track error is equal to distance of track upon distance gone multiply by 6060. So the distance of track is 6 and the distance gone is 80 multiplied by 60. 0, 0 cancels out. This is 3 and this is 4. 60 is 18 divided by 4 is equal to 4.5 degrees. Since it is onto the starboard of my track required, it will be assigned as 4.5 degrees to the starboard. So therefore, the track error between these two is what we call it as a 4.5 starboard. Now, if I do not do anything, the aircraft will keep going off the track and they keep following this line. Right? So now, if I turn left by 4.5 degree, why 4.5 degree? Because this angle is going to be this angle. Okay, 4.5 degrees, my aircraft will start going parallel to the track. Now, at this point of the time, as I said that this calculation may not be required for the final calculation, but I have given this calculation for as a practice. Now, at this point of time, the pilot has given some alteration of heading and he finds himself 2 nautical miles to the port of track at time 1048 and at a distance of 100 nautical miles. If I draw a line, okay, this line, this angle now will be equal to this angle and it will be this angle. Now in this case, this is the angular difference between the track made good and the track required. So the angular difference between the track made good and the track required is what we call it as a track error, and the track error will be assigned as port or starboard depending upon the track made good lies to the port or starboard of the track required. So in this case, this is the angular difference between the track required and the track made good, and since track made good is the port, so this particular track error is going to be to the port. We will find out the value. How will we find out the value? The distance travel is 100 nautical miles. Now in this case, the distance of track is going to be measured from here. 6 nautical miles here. Kindly have a look here. 6 nautical miles here and the 2 nautical miles here. The total distance which has gone off the track is 6 plus 2, 8 nautical mile in this case. The aircraft, if I don't do anything, it would have been flying parallel to the track. Okay, now from the track, it was 6 nautical miles, and on the opposite side, now it has gone 2 nautical miles. So 6 plus 2, 8 nautical miles is the total distance which has gone off. So therefore, I will find out. I'm going to rub the question because all of us are, I have already drawn it here. So now in this case, the second track error is equal to distance of track, which is 6 plus 2, which is 8 nautical miles divided by 100 multiplied by 60. Okay, so this is 3 and this is 2, 5. 8 is 24. 24 divided by 5 is equal to 5 for the 20, 4.8 degrees. Since the track made good is lying towards the port of the track required, it will be assigned as a port. The track error is to the port. Now, this is the track error. So, at this point of time, if I give an alteration of heading of 4.8, I will start going parallel to the track. But my aim is not to go parallel to the track. My aim is to come to point Bravo, for which I need to find out this angle. This angle will be equal to this angle. This angle is what we call it as a closing angle, C-L-O-S-I-N-G angle, or it is in short written by CA. Now, using the same formula, the closing angle will be equal to, now in this case, I am already here, I need to find out this only. So, the distance of track is 2 nautical miles upon how much is the distance left? 120 divided by 60, which is equal to 2. 2 divided by 2 is equal to 1. So this angle is 1, that is closing angle is 1. Okay, so now if I turn a total of 4.8 plus 1 degree, then I will come back to position B. So therefore the total alteration of heading required, the total heading change required is going to be the total heading change required is equal to 4.8 plus 1 is equal to 5.8, which can be round up to 6 degrees. If I turn right 6 degrees, I will come to point B. So original heading was 082, turn right further by 6 degrees, that is plus 6 is equal to 088. So if I turn on a heading of 088, then I will reach point Bravo. This is how to calculate the heading. Now let's find out the time of arrival, for which I will rub this off. Now let us calculate the time of arrival. Here once again, I am not required to find out the ground speed in this leg because this is already passed. Okay, but however, for your practice, I will let you calculate the ground speed from here to here, which is not required to solve the question. I repeat, just this is given just for a practice. The time difference between this and this is 24 minutes. 24 minutes. In 24 minutes, the aircraft has traveled 80 nautical miles. 80 nautical miles in 4 minutes. So therefore, in 6 minutes, which is 1/4 of 24, in 6 minutes, I will travel for 20 nautical miles, right? In 6 minutes, I will travel 20 nautical miles, so the ground speed is 200 knots. Okay? So ground speed is 200 knots. Right? This is for practice only. Now, similarly, I will calculate the ground speed between X and Y, which is the latest ground speed. Okay? So time elapses again 48 minus 24, which is equal to 24. Okay, in 24 minutes, the aircraft has traveled 100 nautical miles. So that means to say that 24 is how many parts of 6? It is 4 parts of 6. 6 4 are 24. So therefore, if I divide this by 4, then I will get the distance traveled in 6 minutes. The distance traveled in 6 minutes is, okay, 4 2s are 8, 25. So 6 minutes, 25. So 60 minutes, it will be 250. So the ground speed between X to Y is 250. Since this is the latest ground speed which I can compute, I will use the same ground speed in order to find the time to point Bravo, which is 120 nautical miles away. So now now the distance is equal to S is equal to 120, velocity V is equal to 250. So time is equal to, now using the formula S is equal to VT, we can find out the time. Time is equal to distance upon speed 250, okay, which is 120 upon 250. So let's find it out. We should come into fraction. Okay, so now I divide 120 divided by 250 equal to 0.48 hours multiplied by 0.48 multiplied by 60 is equal to, multiplied by 60 is equal to 28.8 minutes, that is 29 minutes. Time is equal to 0029 minutes, which will now be added to 1048 plus 1048. Okay, so it will be 8 plus 9, 7, 1 in hand, 4, 2, 6, 7, 1. So 1117 is the ETA. So So this is how we go about solving this kind of a problem.